Are we all set?
We're all set?
Okay, excellent. Back to the full screen.
Yeah.
Okay, good morning, ladies and gentlemen, and thank you all for being here. It's my great pleasure to welcome you here, both as a leader of ACAS and also as your local host. I hope you enjoy our typical Boston weather. We get this kind of weather year-round. I hope you get to stroll through the Harvard campus, which is a historical, beautiful campus. It's kind of quiet right now because the students are out of session, but that's a good thing too. If the classes were in session, we wouldn't have access to this really nice facility, which we also use every other year. Just part of that community. In any case, for the next 2.5 days, we'll have full usage of this auditorium and also the lobby outside. So in particular, you can see in the lobby the stands for the posters. You're welcome to put up your poster now and take it down when you leave. We'll have a dedicated poster session this evening from 5 to 7 with appropriate communication. And I really look forward to that. Now, at this point, I want to echo the wealth of thanks that Tracy expressed. I really want to thank Brenda and Mathieu, who's sitting outside. If you have any questions about logistics, ask Brenda. There won't be anything without her. So please ask her if you have any issue. She'll take care of it. Also, I want to thank Bruno, Jess, Patrick for taking care of the AD and also the remote access, which I hope is working just fine for people who are listening to me now but not seeing me. Okay, so this is the 7th meeting of Air Quality by the Science of ACAS. And as you see over the years, since we started in May of 2011, we've been all over the country engaging in dialogue with air quality managers. Our team is dedicated to increase the value of earth science products for air quality management applications. And I'll talk more about this over the course of my talk. But so critical to that is a process by which we actually get to meet with air quality managers in different parts of the country and tell them about the resources from earth science, both data and models, and also hear back from them about pressing needs. And these meetings have both an information and an action purpose. The information is a two-way exchange between what earth science data can provide and what air quality management are. And the action is, okay, ACAS, what can we do on the basis of the needs that we've heard in terms of making things happen and responding to the needs. Now, let me very quickly go through the agenda, which is kind of guided by the goals of this meeting. So we have 2.5-day meetings. The first 2 days are really the ones in which we should engage everybody here. After we go through the overview, we're going to have a special presentation on TEMPO, which is Geostationary Satellite Instrument. We have here the PI of TEMPO, Kelly Chance. And as you will see, that instrument, to be launched in 2018 or 2019, is going to really revolutionize our ability to monitor air quality in space. I'm really excited about that. After that, we're going to have a couple of sessions on the ACAS project, kind of for us to hear about what each other's doing, but also to talk to the broader community about what we're doing and how exactly it's relevant to air quality management. And then later in the afternoon, we're going to have our first of 2 air quality manager sessions. This is probably the most important part of the meeting, where we're going to get a presentation from air quality managers and policy analysts on the national scale. And then we're going to have a panel in which we get to throw questions at them and try to get a feel for what the pressing issues that we need to do. And we'll do that the following morning with more of a northeast perspective. One thing that we've been trying to do as we go to different regions of the country is get a local perspective on air quality. We're lucky here to have a number of states represented in the northeast. We had never been in New England before, so here we are. And this is going to be very, very interesting. And we're also going to have in the morning a session on communication and outreach. What is NASA doing to try to send its air quality message to managers, but also to the public, and what more can we do? Then we will have more ACAST and satellite project presentations. We don't just have ACAST members here in terms of the Earth Science community. We also have a number of other scientists working with satellite data and for air quality applications. And look forward to hear from that. As I said, we're also going to have a poster session this evening, reception, and Brenda McKeon will double as your bartender. Okay, finally, let me say something about the last half day of the meeting. The last half day of the meeting is more internal ACAST affairs, but if you're interested in our activities, and in particular in our target teams, I'll say a little more about, I really would be very happy to have you here. This will be an opportunity to talk about what the target teams are doing, to talk about what action items we heard from the Air Quality Manager session, what should we do about them, and then go through some other organizational issues. Okay, so with this, let me tell you a little bit about what ACAST is about. ACAST was established in May 2011 with the goal of better exploiting Earth science data and models for air quality management and applications. Now, this being NASA, you think satellites. And certainly satellites have an important role to play. But it's not just about satellites, and it's not just about NASA. It's about all the Earth science resources that air quality folks are not used to take advantage of, but can be really relevant for air quality applications. Satellite, of course, but also aircraft observation, ground-based networks that are used for global climate or other applications. Models that are developed for Earth science applications but may not be familiar to air quality management, global chemistry climate models. And with these resources, which can be from NASA but can also be from other US agencies, hell, can be from other agencies around the world. We're really not exclusive in any way. We try to get the data where we can. We try to serve a very wide range of air quality applications, which particularly focus on new issues that are faced by air quality managers and for which the traditional resources are inadequate. For example, background emission concentration, methane emission, for example. Now, we have 19 members on the ACAST, and these members are funded for 5 years. The total team is funded at the level of about $2.5 million a year, and these members represent a very wide range of expertise in satellite retrieval, in aircraft observations, in construction and emission inventories, in chemistry climate issues, in chemical modeling. And all of them share a commitment and an increasing understanding of air quality management issues. Now, what makes ACAST unique in that regard? First thing is that all of the projects that we do have to have this very strong air quality management application. Now, this is very important in that the projects require partnership with air quality management. And we'll talk about this in just a minute. They got to have a deliverable. That is, the air quality managers got to be able to get what they want in terms of the research or the application being produced. And now, a very important part then is to have a continual dialogue with the air quality community as to what is it that you need. Because the point is that the issues involved in air quality management evolve very rapidly. And we've seen this over the past few years. 3 years ago, the kind of issues that we were hearing from air quality management were quite different than the ones we hear about today. And ACAST is intended to provide a very flexible way to respond to this evolving. In other words, the members of ACAST have this continuing grant from NASA, but without prior requirements in terms of the projects that we should do. Most of the projects that NASA supported are in response to solicitations in which you submit a proposal and it gets reviewed, eventually you get funded. There's typically, an 18 months or something gap in the time that the solicitations come and the time that the research can get started. Well, ACAST kind of short circuits all of this, because as soon as an issue comes up, we can go ahead and address it. The extremely flexible to that. One particular aspect of this are our target teams. Our target teams represent an independent product line that's applied to the ACAS team on a yearly basis to pool our expertise among several ACAS members to respond to particularly pressing issues in air quality management. I'll talk a little bit about our year-free target teams that are just getting started and how we put them together with extensive input from air quality managers. Now, these are the year-free target teams. As I said, they're just getting started. They went through an extensive vetting by the air quality management community, and many of you here may have been involved with this. We started with, it was about a year ago, we started with 15 projects that people on the ACAS team came up, and then we did a survey of air quality managers around the country. We had over 100 or so. Asking them to basically rank them, and also if they had any other ideas. And out of this, we whittled it down, and then we whittled down further through a process of review involving both the ACAS team and also a group of 5 or 6 quality managers. And from that, we came up with that list of 6 target teams, which are now getting started. The first team is called the use of online tools for air quality management. The second one is about the changing face of pollution events in the eastern United States, also in Indiana. This is not their grandparents' culture, their pollution problems anymore. The third one is about natural processes that are important in air quality models, but for which the air quality management community doesn't really have the tools. Think climate condition, think policies, different varieties, and so on. The fourth and fifth projects are about improving our knowledge of emissions on the basis of satellite observation. And in particular, we've been responding to a pressing need to understand what's happening with oil and gas emissions as those oil and gas are increasing rapidly in the United States and also in Canada. And finally, an air quality reanalysis, basically trying to reconstruct a complete field of concentrations relevant to air quality for the purpose of being able to do exposure assessments, being able to initialize air quality models, look at consistency between different measurements in terms of our understanding, and so on. Okay, now the Tiger teams are just an example of a much broader scope of the ACAS projects that are led by individual members. And those projects encompass a wide range of themes, and we'll hear about those themes today and tomorrow. They involve, as I was saying, a wide range of earth science resources, not just satellite, but also suborbital observations. Suborbital is, by the way, NASA's jargon for anything that's not in space, and also model. So what I want to mostly draw your attention in the slide is to the range of air quality agencies that we're working with on a national level, on a regional, on a state and local level. And we've been engaging in particular with a number of states of which one thing that's really missing here is any state in the Northeast. So hopefully, I don't know, well, maybe they're not. But in any case, we certainly hope to fix this at this meeting. Okay, so as I said, we've been going around the country listening to air quality managers. Our last meeting was in Houston in January. And here I'm just putting up the major issues that were raised by air quality managers at that meeting, and some of which we've taken action, and others are still hanging, and I'd like to do something about it. One of them was making top-down constraints on emissions more useful for improving emission inventories. That is, and the central piece of that is having a better dialogue between the atmospheric community and the emission inventory. We're very fortunate today to have Alex Azzurro from EPA, who is part of the emissions modeling, to tell us the issues that they're facing and try to get a dialogue going on there. Issues of boundary layer ventilation by Fairweather tiles were raised, and it's something that we're just starting to work on. Issues of background ozone, that's really been a big issue raised over the time of ACAS. In particular, the challenges in controlling ozone as we get close to the NAAQS. And with the changing NAAQS, it's very likely that in the next round of the revision, the NAAQS is going to down to a level between 60 and 70 feet. My bet is billion. Sources of methane are a rising issue with increased oil and gas extraction and increased interest in coupling climate and air quality management issues. Using satellites to observe long-term trends and PM sources of residential wood burning. This is an issue that's there of great importance in the Northeast. It was really interesting to see that it was an interesting issue for the South Central U.S. As well. Okay, now a testimony to the value that ACAST has brought to quality management is a special issue of Environmental Manager that came out in February and dedicated to ACAST. And this was really great for us because it really, I think, both was very good for our visibility, but also was a testament to the fact that we're doing this right. And we have a number of papers in that EM special issues covering different parts of the ACAST activity offered by the ACAST investigators. Okay, for the rest of my talk, and I just wanted to sort of 5 minutes into this or so, I want to give you a quick overview of some ACAST highlights. And these are results from the past 6 months, so since our last meeting, that I think illustrate kind of the range. This is work from Marlene Fiore working with Olivia Clifton, a student at Columbia, and it's about this shift in the ozone pollution problem in the Northeast. It is really something, the landscape for ozone is changing. Now, we know that we have a lot of ozone now in the Mountain West that we're concerned about, but in the Northeast, our issues are also becoming different. With the reduction of NOx emissions over the past decade, we've effectively brought down ozone during the summer, but we really haven't done anything with ozone in the shoulder season. And if anything, in the winter, ozone may be increasing as a result of increasing background. So what Arlene has been doing with Olivia is to use her couple chemistry climate model to look at what may be happening in the future as emissions, domestic emissions, keep going down, the emissions in the developing world may increase, and also the climate is changing. And what they find, interestingly, is as you get into the 21st century, the seasonal cycle reverses ozone. And what used to be a summer pollution problem now becomes a spring, fall, and almost a winter problem. And you can ask Arlene why that is. It has to do with background. Really an interesting issue. Okay, I talked about ACAST helping air quality models by providing information that they don't usually get from their standard tools. One of them is photochemical environment, which is of course critical for ozone and SOA formation. And Dick McNider of the ACAST team has been working for some time with their quality manager to improve representation of clouds, which is always a tricky issue. And more recently, he's been working to provide fields of photosynthetic radiation, or PAR, which are essential to simulate emissions of biogenic VOCs. And for this, you get great constraints from satellite observations, but it takes some labor and some handling to convert the insulation that you observe in space into PAR. And this is something that Dick McNider has been doing and is now serving to air quality models. Another product that is being developed as part of ACAST are PAR injection pumps for purpose of air quality monitoring. What I'm showing you here on the top left, on the top right, I'm sorry, is observations from a campaign that's called Seekers that we did last summer, and that looked at a fire in California whose plume was transported all across the United States. And critical to the transport of that plume is the fact that the injection of the fire emissions were in the free troposphere, so that the plume could travel a very long distance carried by the westerly winds, and then eventually fumigate the eastern United States. In order to be able to properly represent this, we've got to understand the injection. Satellite observations are great for that purpose. They can actually tell you how high the smoke is. And then you can try to model this based on your understanding of the local ecological conditions and fire radiative power, and come up with a predictive tool for fire injection. This is something that's done by Edward Heyer, ACAST BI, together with his postdoc with Peterson. Finally, this is work that's done here at Harvard and that my graduate student Lei Zhu worked in the Red Emission, in which, for the first time, we we've been able to use formaldehyde measurements from space to constrain anthropogenic VOC emissions in the United States. And this is really a big issue as we try to look at emissions from oil and gas activity. Formaldehyde is something that we can observe quite readily from space because it absorbs into UV, and it's a tracer for emissions of highly reactive VOC. We've been using it for a long time to look at isoprene emissions in the US and around the world, and to look at anthropogenic VOC emissions in polluted parts of the world, in China. But we had never been successful to actually pick up anthropogenic emissions in the US. But what we've done in working with another ACAS PI, Brian Duncan, is we used an approach called oversampling, which sacrifice temporal resolution in order to get very high spatial resolution signal. And when we do this, we see beautiful things. We see the Houston plume at levels that we can actually quantify and show that the EPA emission inventory is about a factor of 5 too low. But we can also see industrial plumes in Port Arthur. We can see the Barnett Shale, Dallas, Fort Worth, and we're working now to try to see where we can better oil and gas recovery regions, and looking forward to hearing from people here about places that we can look at. Okay, now we're also use ACAS resources to contribute to field missions. In particular, we have played an active part in the Discover AQ campaigns, which NASA has been using to try to see how much more we can use satellite conservation for air quality applications. And we're going to be active members of a fracking campaign that's going to be taking place this summer. And David Edwards, who's a PI on ACAS, is very actively involved in this, and also our oil and natural gas Tiger team. This is a campaign that's going to be taking place over Colorado near the Front Range, where there's extensive development of oil and gas and trying to figure out the emissions associated with that. So ACAS is not just about research activities, it's also about generating products for the air quality management community. So PI Devin Hensig has been producing this GLIMS product, which allows air quality managers to figure out the climatic implications of any air quality management strategy in a very straightforward way. Ann Thompson, ACAS PI, has been producing operational forecasts for the state of Maryland that not only give you a deterministic forecast, but also a probabilistic forecast, really important. How likely are you to exceed the air quality standard? Tracy Holloway has been producing the WIPS data site in which you can get satellite data served to you in a very user-friendly way, the way that you can readily validate that. Use to validate your quality. Now, another important activity of ACAS has been to try to educate the air quality community in terms of the resources that satellites can offer. And Brian Duncan, ACAS PI, has just published this paper in Atmospheric Environment, which is open access, which is basically an idiot's guide to using satellite data. And in particular, what is it that you actually get from satellite data? What are the common mistakes to avoid? This follows on another primer that was published last year by David Streets, again in that department, again involving 9 ACAS PIs on how do you actually constrain emissions from satellite observations. Okay, this is my final slide. As I said a few times in my talk, continuing dialogue with the air quality management community is critical to the success of ACAS. And we have a wide variety of ways that we are doing that, some of which I've already mentioned. And I don't know if I want to go over this too much. We have the media center that's led by Tracy. Tracy will be talking a little bit more about all of this on Thursday morning. She just told me that our Twitter user base has quadrupled over the past 6 months. And it's not like we were starting from a low number, too. It's, we now have over 1,000 Twitter followers. Almost. All right. So with this, I want to. I think that. All right. With this, I want to thank you very much for being here. Let's get this show on the road.
Our next speaker is John Hamer.
Sorry, so just a quick announcement for all the speakers. For the 9 of you who are watching at home, we've gotten some comments that it's hard to hear, so the mic for the live web recording is actually here on the laptop, so if you could stand close to the laptop, that would be great. Thank you.
Can everybody hear me okay? Thank you. Good morning, everybody, and again, a lot of thanks to Danielle for hosting us here at Harvard this week. I'm just going to give you a little bit of a extremely high-level overview of some of the big news items that have been going on at NASA headquarters in the Applied Sciences program since we last met in Houston about 6 months ago. Probably the biggest news item was the launch of the Global Precipitation Mission, GPM, from the Japanese space agency, JAXA's space base off the east coast of Japan, February 28, 2014. We began receiving first light images from GPM about somewhere around March 25th or 24th. And I'm glad to report that everything with GPM is nominal, and we are already receiving, like I said, good science already from it. That is still in the very experimental phase. But we expect in August that the GPM data sets will begin to be released in an actual science alpha phase there for everybody to use that through the NASA DAX and to continue to build on the heritage of the Tropical Rainfall Measuring Mission TRIM, which is also still operating nominally. So we have, at least for a little while, both of those satellites on orbit looking at precipitation across the globe. So with the addition of GPM, we now have 17 satellites in low Earth orbit, continuously studying Earth's weather and climate for research and applied purposes. And as I'm going to show later, this is a very big year for NASA. GPM was just the first launch of what we hope to be several successful launches this year. One of the biggest years in over a decade for NASA Earth science. Some other major news items. GEO, the Group on Earth Observations, had their latest work plan symposium in Geneva at the end of April. This was in order to formulate the 2015 to 2020 work plan for the Group on Earth Observations. We are heavily involved in the Applied Science program in many of the communities of practice across the 9 societal benefit areas of GEO. Particularly with me, it's on the public health, on the health community of practice side, which includes air quality. In fact, we hosted last July the health community of practice for GEO's international team meeting at George Washington University. NASA hosted them last July. We're hoping that there will be another meeting this year in Geneva, the health community of practice, but it's not been settled yet on who is hosting that and the exact logistics for that. Also, I'm sure many of y'all saw that the National Climate Assessment was released on May 6th. Certainly, NASA and all the participating agencies across the federal government issued a lot of press releases, a lot of social media that day, highlighting our contributions to that report. There's a very large section on health. Health was one of the areas that was particularly highlighted by the administration. It is considered to be a very important framing aspect for the National Climate Assessment and the issues of climate change in general, because health is really where climate change issues hit people at home. And so you've already seen over the past year, and I think you're going to see coming up over the next year, more and more emphasis when the U.S. GCRP and other federal consortiums are discussing climate change, a bigger emphasis on the issues of health and air quality and how it actually affects people's lives day to day. The next launch coming up is OCO2, the Orbiting Carbon Observatory, our first mission to actually measure the carbon budget of Earth from orbit. That will be launching on July 1st from Vandenberg Air Force Base in California. So we're looking forward to a successful launch there. Our ROSES 13 solicitation for this past year, element A.44 on health and air quality, the proposal due date closed for that at the end of April. We had 68 proposals that came in through that solicitation. Again, that solicitation, to remind those of you who proposed or maybe didn't, that it's a 3-year period of performance with a budget expected of about $2.75 million per year. So that's going to be about 6 or 7 selections. I wish that was better because it's only going to be about a 10% success rate, but that's the budget environment we live in right now. I'm going to continue to fight to get that number up. See, I've already fought a lot. I had the Band-Aid across my nose, but I'm going to try to fight even more to get that number up a little bit when we start funding these in FY15. hopefully, because we have got so many great projects, I can go to the steering committee of Earth Science and say, 6 to 7 can we have? 7 to 10 or something like that. And just keep our fingers crossed to get as many selections as we can from that solicitation. We expect to make those selections in October. Right now, peer review panels will be held in August. I expect to go to steering committee with their recommendations in September, so hopefully we'll have selections announced in October so we can begin funding those at the beginning of the fiscal year. The next solicitation is planned for ROSAS 2015. We do not have one in 2014. So the next one will be coming up in ROSAS 2015, which will be released in February 2015. The exact nature of that solicitation is still TBD. NASA Health and Air Quality sessions over the past few months. We had many sessions at the AMS annual meeting as part of the Conference on the Environment and Health, of which NASA sits as a member of the Standing Board on the Conference on Environment and Health. So we had many sessions across AMS, led once again very ably by Sue Estes, who organized many of those. The AMS Washington Forum was held in April. This is a yearly forum that brings together policymakers and scientists from across the AMS to meet with people in Washington, be they congressional staffers, be they federal executives, in one session where the rules are that anything goes, anything can be said within the room, it's not recorded, it does not leave. So it can be a very frank discussion. There was an entire session on health connections to policy that I chaired at that meeting that was very well received by not only attendees but also the people who were there from across the executive branch and the congressional and the legislative branch. We had an applications workshop for the Orbiting Carbon Observatory in April at University of Maryland. We're trying to do these application workshops for each mission before they launch, and then once again after they launch, to look at not only what we can do with the data prior to launch, but after launch, what we are doing with the data, what are issues with the data, how can we correct that to make applications easier. Currently, we are planning the next one that would be coming up, I believe, would be an NPP applications workshop that we're planning to hold in Huntsville, Alabama in the November timeframe. The American Thoracic Society, they had their annual meeting in San Diego at the end of May. We had a session there as well looking at issues particularly on wildfire issues, smoke, aerosols, which was very timely for San Diego because they were having quite a few wildfires across that area at the time. And we also have coming up next week the Air and Waste Management Association's annual conference, which we're having several sessions and panels at that meeting, as well as a large NASA exhibit. That's going to be in Long Beach, California. Many thanks to Ali Omar, who helped organize our sessions at that conference. So this is the President's FY15 budget that was released at the beginning of March. It was released very short, a few days after the FY14 budget was actually enacted. So then the President's, the Office of Management and Budget issued the President's proposal for the FY15 budget across the executive branch, and this is only looking at NASA Earth Science. So you see in FY13 what we actually had in NASA Earth Science, about $1.6 billion. That was during sequestration. That's what it ended up being after sequestration cuts. In FY14, we got an active $1.8 billion by Congress. And then the proposal for FY15 is $1.77 billion by the President. And you can see the out years there. And the out years, OMB always puts an asterisk and says those are considered notional, which is bureaucratic speak for our best guess. When you drill down into that budget to applied sciences itself in FY15, $36.3 million has been requested by the President for the Applied Sciences program, rising to $39.7 million in FY19. Bit of a caution there. Literally for the past 10 years, every president's budget has said over the next 5 years, applied sciences will raise up to $40 million. And they say that every single year. And we always stay at $36 million for the current request. So I would not put a lot of emphasis on getting another $5 million in the next 5 years. But it is, particularly in this budgetary time of budgetary austerity, it is a very solid commitment from the administration to NASA, and particularly NASA Earth Science, because it's very consistent with the FY13 and FY14 President's request. And I will also say that currently up on the Hill, they are much further along in working on NASA's budget than they have been the past few years, and they are treating it very favorably and treating the President's request very favorably. In fact, that it may end up being a higher number enacted than what the President requested for the agency and even for Earth Science. So we have a large vote of confidence from not only the executive branch but from the legislative branch on the work NASA has done in Earth Science including transferring some additional responsibilities to the agency for some of the climate data records that were originally being accounted for at the National Oceanic and Atmospheric Administration. And so we certainly are in better shape than some of our colleagues across the executive branch. The one little negative here from the budget is due to some of the cuts and due to what was considered already with an OCO2 successful launch and capabilities that we would have on orbit. OCO3 was canceled from this budget, and it was going to be an instrument on board the International Space Station, and so that has currently been canceled. Now, that's kind of contingent again on a successful OCO2 launch. If we have that, then we believe we have enough capability there that that was not necessary at this time, so we can keep our fingers crossed. So again, this is just another overview of the budget and some of the highlights that the administrator of NASA, when he's talking about Earth science, some of his talking points. Again, that we're launching the Soil Active and Passive Storm Moisture Active Passive Mission SNAP. Also, the SAGE 3 mission that will be mounted on ISS. This budget formulates and develops the upcoming missions of ISAT-2, Grace Follow-On, SWAT, Cygnus, TEMPO, and a sustained land imaging capability, building on the Landsat heritage and expanding it. Develops and implements plans for measurements of solar radiance, ozone profiles, and Earth radiation budget. This is some of the additional responsibility that I was talking about that was given to NASA in this budget. Maintains weather and climate change modeling capabilities to enhance our forecast accuracy, operating over 21 Earth-observing spacecraft, and maintaining robust research and analysis, airborne science, technology development, and the GLOBE educational program. So some of the communications highlights over the past 6 months that have gotten a lot of play at NASA headquarters and been featured on NASA website have included, and from our last ACAS meeting, the story that was on Texas NPR about ozone issues there in Texas. We got a lot of play out of that at NASA headquarters because of the pickup by NPR. Also, the highlight on the NASA webpage about increases in India's sulfur dioxide emissions. In fact, a slide on that went directly to our big boss, Mike Froelich, who's head of Earth Science at NASA. And also, in March, we had another NASA web feature on health costs of air pollution from agriculture that came from ACAS that also got a lot of play within the agency. Danielle already mentioned the EM magazine. That has really been well received. I keep a stack of those magazines on the front office desk in Applied Sciences, and they're gone every few days. People are really come by my office and want to talk about it and have been very impressed by that publication. So kudos to everybody on that, because that really got a lot of visibility for ACAS within NASA headquarters and NASA Earth Science. We also had in the program at large a special issue of Geocarto International, NASA Earth Science Satellite Data Applications for Public Health. This was published online in April. It will be published as a double print issue later this summer. It includes articles on many of our public health issues, but also, for example, on aerosol optical death by Yang Liu at Emory. So we have air quality as part of that issue as well. Some upcoming events, we have, again, the Airways Management Meeting coming up next week in Long Beach. The Precipitation Management Missions Science Team Meeting, next Science Team Meeting, that's for GPM and TRIM missions. It's going to be held in Baltimore at the beginning of August. And in the beginning of November, the American Society for Tropical Medicine and Hygiene, ASTMH, will be having their annual meeting in New Orleans, where we will have a session discussing some of the satellite applications for vector-borne diseases. And like I said, this is a very big year. In fact, NASA Public Affairs Office has issued this huge communications campaign called Earth Right Now. The catchy phrase you're planning to changing here on it, to highlight the missions that are being launched by NASA Earth Science this year. It's the biggest year for us in over a decade, starting with GPM's successful launch. So we can put a big green check there. We have coming up a cloud aerosol transport system, LIDAR sensor that will be on board ISS. We're planning that launch right now in September, but those are kind of missions of opportunity of when we can get that up, depending on other cargo going to space station. So right now, that's tentatively says April there, but now it's been pushed back to September. July, OCO2 coming up, like I said, July 1st. Then at the end of the year, probably late October, we'll have SMAP and its launch. And then the SAGE 3 mission as well, the ISS, coming up in March, probably 2015. So it's going to be an extremely busy year. And just to wrap up, I want to say that, we had the budget finally enacted in early March for FY14. It's always this, huge delay. That's why I'm very happy to say that Congress seems to be more on the ball this year and a little ahead of the game. Because surprisingly enough, it's an election year, and during election years, they like to get out and go campaign, and so they get the budget done more quickly. So it's always to our advantage in those years. But we finally got our money passed in March, but we did not actually get the money released to NASA from the Treasury until about May. So that's why, again, there was the delay in trying to get Tiger Team money out. But I'm glad to say that as of last week, except for just a few of you, I'd say 90% of all continuation core money and Tiger Team money's paperwork has been sent out by me to the NASA Shared Services Center for processing. So some of you have it now. I've seen a few of the mods come in that some people have already received it, but if you have not, it should be within the next 3 to 4 weeks as they process those. There's only a couple of you that I've already talked to that know that we had a couple of glitches trying to figure out the budget. But other than that, 90% of the money is out my door and just has to be processed to get to your door. So with that, I'd take any questions or wrap up there. Thanks all for being here.
Any questions?
I want to mention that we have copies of that environmental manager special issue outside of this room. You're welcome to help yourself to it. And we also have a stack of really nice particulars produced by Brian Duncan showing trends in NO2 in space being non-emission control. Again, help yourself to it, show it to your friends. Okay, so we have copies of the air quality user. Yes? Yes, the presentations are actually posted online in streaming video right now, and they're going to be made accessible online.
Okay. So we're a year and a half into the Tempo project. And a month away from having had our second Tempo Science team meeting down at NASA Langley last month. It says that it's the status, but it's also an introduction for maybe half of you who aren't really up on what Tempo does and what the schedule is, etc. So Tempo is NASA's first Earth Venture instrument. So we were selected a little under 2 years ago to be the pathfinder for that. Tempo is a spectrometer that is being built for us at Howard Aerospace. Project management is being done for us by NASA Langley, and it has a lot of universities, a lot of institutions, and a lot of people in this room are actually involved in it. The international collaboration includes the Koreans who are doing the Asian geostationary ones. Includes the European Space Agency, because they're doing the European geostationary Sentinel-4, and it also includes Canada and Mexico, because we are also the Navy instrument. So, like I said, we were selected a little under 2 years ago. We will deliver the instrument in May of 2017, and NASA is arranging the hosting. So it's a hosted instrument that will fly on a commercial geostationary communication satellite no earlier than November of 2018 to 2019 is more likely. During daylight, it will provide hourly observations of the gases that you'll see in a minute and the resolution that you'll see in a minute of things that are important to air quality. It's a UV visible grading spectrometer, so it's from the heritage that we started with the Skiolock instrument many years ago. The dome instruments and OMI ops, so all of the capability, the algorithm physics, and the algorithms we developed translate over very readily. So that's the heritage from the Rio missions. And for the first time, we will have an instrument that is specifically designed and built to combine the UV and visible ozone measurements to improve our ability to see ozone in the boundary layer. So it's aligned with the decadal survey. It makes a lot of geocache. It's not geocache. We took the euphemism sometimes. It's Pathfinder geocache or whatever it is. But in any case, it's real and it's going. So it could respond to a phasing information say by an infrared instrument. And as I mentioned, it's the North American component of the international constellation. This is Joe Weber, the manager up at the SAO. SAO is about a kilometer down and far beyond the campus. It's part of the Center for Astrophysics together with and the low Earth orbit satellites that we're talking about, the 8 Fame, and all of those, are here at about 800 kilometers in some synchronous near polar orbits, very close in. And Joe here is looking at it from Geo. It's a lot further away, challenging pointing. Make it a bit more difficult, but we think we have all of that well in hand. So here's what we're going to measure. These are 4 spectra from our one instrument. Basically show the range of conditions that we see on a terrestrial type planet, and the 2 boxes are for the 2 CCUs and tempo will be measured. So most of the trace gases and the UV ozone here, and in the Chappie Rim over here, and lots of other videos that the field of regard is shown here during the iteration of proposing and going to almost the implementation phase now. We've changed a little bit of ground footprint, but not much. So this is what we're going to measure every hour here. And this is the footprint for the center of the field of regard. So each hour, this slit, which is actually 4.7 kilometers wide, but exaggerated so you can see it, will go from east to west to measure 2.5 million spectra round pixels. In a little more detail, we'll do this. And while we're doing that, I want to point out that we had what's discussions in this? Discussions included what chemistry experiments can we do with the same when we're not doing our normal hourly from east to west. So normally we can do this, we can do other things. The buttons that we can push or the dials that we can turn are where to start, where to stop, and how long to get there. So, for example, sometime we're doing opening phase, we'll go over the cities to see how much things often run. I can by looking at so there's a lot of interesting things that one can do in addition to the normal science in this operation. So if we're at that size at the center of the device, other places, but maybe in oil sands we're about 20 kilometers in resolution, South Mexico City, like that. And here are the things that we make. Ozone, of course. So boundary layer ozone, pre-filled stratosphere ozone photo, NO2 formaldehyde, which is something here, and then SO2, lyophil, aerosol properties, acid waters, and properties also And this is justification for hourly basis. So only will measure NO2, say once a day here, and Skiamaki may measure it here, and only may measure it once a day here. But we will be able to track it. This is a bit of a demonstration and the story that goes on with Thomas Pelosi, who took some OMI data and did what Danielle and his group are doing with formaldehyde data that will reduce them, and looked over sacrifice temporal resolution with facial resolution. Okay? So OMI pixels, depending on where you are on the swath, are sort of like two blobs in the valleys. But by collecting a lot of data and oversampling, we're able to get it down to where we got. Yeah. So, two of these boxes wide and one box tall is the normal tempo measurement. So this is what more or less what tempo does hourly over LA. But in addition to that, if you want to sacrifice the hourly to look at even greater details, you see, now we think we'll be able to get down to the 1 kilometer, down to 1 kilometer sort of range in subset. These are barely visible here, but these are red boxes that show where NASA masters will be measured on C. Okay, and for our Mexican colleagues, Mexico City is this basin here, and it's somewhat bigger than that, and we're also bigger south, so the resolutions of it gets extremely long. This may be the most important slide in my presentation, because all you heard this morning about making satellite data accessible now to our scientist colleagues that will order products, and the firewalls will turn on and all of this stuff and know how to use it. But more local and regional efforts may want different things. And the Environmental Protection Agency has developed a tool called the Remote Sensing Information Gateway. Very nice colleagues down there with them having shown me this. This is a tool that runs on a server at the place it produces data from. So they have programs running up at SAL and it is a visualization and subsetting tool so that you can go in and say, well, I want to look at just, say, formaldehyde over hospital. This grid, this kind of grid, and it will do all of that and give it to you in a very useful manner through the garden hose rather than fire hose. So this is a very nice way that we're looking at making tempo nearness from it. So with an hour or two of inspection, people can get what they want when they want it. And if other tools become available, we would certainly want to talk about those as well. So here's the summary and status where we're at. So it's a Pathfinder for NASA. It's the first of the Earth instruments. So it's the test case for the initially hosted instrument. We are extremely cost capped, and we will use a commercial, competitively selected commercial host. How we selected about a year and 2 months from now. We're currently a year and a half in. We're doing very well. We're on budget. We're on schedule. We had first reviews last November. We passed our PDPD, and now we'll have our preliminary design review next month. And that will do the decision, see the decision, go into the actual implementation sometime this fall, similar as successful. So I said that, and I already mentioned that delivery is 3 years for launch no earlier than late 2018, and that is.
You know, we just been with very about earlier, very fast grid ozone. I wasn't clear if that applies in virtual as well, and how do you.
Ozone is the only one that we've been able to do it with, and that's because we have different kinds of spectroscopy that contribute in different ways. So that the scattering depths in UV, and then in the visible reflective things, you see all the zooming is over there. As it has worked out, most of the details that complicated didn't able to see in the visible. So it's having information over structured information over a broad range of spectrum. Happen. And none of the other molecules really have that in the UV because we've tried with NO2 but never have got there. In the infrared with CO, we can combine thermal and Maxwell with and get some vertical information. But so far, that's about it.
Do you expect an issue with finding virtual hosts, for example? Will you be able to be at 100 west longitude, or you may have to be flexible?
We're fairly flexible, but at the moment, it's 80 to 115. And we get most of everything. We started off with a broader range, basically what we're using left out. And there are plenty of hosts in there.
So, on the sleep of the sun side, you're basically getting Mexico City, just Mexico City. Is the sensitivity raw off at 7%, or is it full? Obviously, the resolution
You have full sensitivity to the
Great. Well, then I think we'll say thank you so much. Super exciting. And we're now transitioning to our next set of talks, looking at satellite data for air quality applications. And our first speaker is Brian Duncan from NASA with an update on Aura products, only NO2 trends, and stratosphere treatments. Thanks, Brian.
Okay, I just want to quickly, I won't go into detail on this, but I just want to point out that the Air Quality Users Guide was published last week. And it's not just an ACAST effort, it was an ACAST RSET effort. And RSET stands for the Applied Remote Sensing Training Program. It's a NASA program, and Anna Prados is in the back. We were partners in crime on this, and she'll tell you about the RSET program and all the resources available to end users tomorrow at 9 a.m. Okay, just to give you an update on Aura, I'm Aura's Deputy Project Scientist at NASA, and a number of data products from Aura have been widely used by the air quality community, and you've already seen some of that, including from the ozone monitoring instrument, NO2, formaldehyde, and SO2. And I just want to say that these retrievals are always being improved over time. So, and just recently, there's been some important improvements in all three products. And if you're interested to hear about that, let me know. Okay, moving on to the main portion of my talk here, I'm going to talk about stratospheric intrusions. And most of us know that deep stratospheric intrusions impact surface ozone out in the Rocky Mountains, usually in late winter to early summer. And Arlene Fiore and Mangyun Lin, they're both ACAS members here, have led the charge on this, and they've done quite a bit of interesting research and presented that over the last few ACAS meetings. And in fact, Mayun has a talk about it at, today in the early afternoon. And another ACAS member, Brad Pierce, has developed a forecasting tool for these intrusions that you might find interesting. So I'm going to take this a step further. I was inspired by their work, and I started to look at the possibility of these intrusions affecting surface ozone in the eastern U.S. in summer. And most people told me I was nuts to even think about this, but I was inspired by the Discover AQ mission in July 2011. One day, the ozone just didn't make sense. It was after a cold frontal passage, and I knew about Mayum and Arlene's work, and I thought, I wonder if that was a stratospheric intrusion. So it turns out it was, and it turns out they were more frequent than we thought. In fact, at least 2 days had very clear intrusions out of the 14 flights, and there were a number of days that had stratospheric air in the vicinity. It passed by at certain times of the day, but it wasn't this classic intrusion type of an event. So Ann Thompson knows about these intrusions. She's known about them for years. She's another ACAS member, and she has a talk today at 2, and she'll tell you more about that. Our talks are complementary here. And the importance of this for the eastern U.S. in summer is the relevance to background ozone, because these intrusions are occurring and they're affecting the free troposphere regularly. And also because as NOx keeps decreasing, our ozone is decreasing from anthropogenic sources, and so this becomes relatively more important. And so the question I'm asking is, do these intrusions really affect air quality in the boundary layer to any significant degree? And as I said, we use NASA Discover AQ fill campaign data and the NASA GEOS-5 global model. Okay, this is a first. These are first couple. This slide is, shows a couple of satellite data products that we found useful for intrusion. This first one here on the bottom. Let me see what have I done? There we go. Okay. Okay, so this first one is from the AIRS instrument. It's on the Aqua satellite. It's a total ozone column, and people have found that if you see a tight gradient here in the total ozone column, that's usually indicative that there could be an intrusion event happening. And here's the AIRS relative humidity. It's on the Aqua satellite. At 700 millibars, you can see how dry the area was. So when you bring down ozone-rich stratospheric air, it's dry. So you can see this in the satellite data. And these type of events occur typically after a cold front passes the area, and this intrusion wraps around this low pressure back over Maryland. And here's just a true color image from the MODIS instrument on the Terra satellite, and you can see the skies are completely clear. And for anybody who's lived in Washington, D.C. in July, that's a pretty unusual thing to see totally clear skies. Okay, because it's difficult to see these intrusions with satellite data, we have to use models, and I'm showing the NASA GS5 global atmospheric model output here. It's a 50 by 50 kilometer spatial resolution model, and that's been shown necessary to capture these fine structures or these filaments of stratospheric intrusions. And so what I'm showing here is a cross-section here through the U.S., 76.5 west. And what I'm plotting here is what we're calling a stratospheric influence tracer. It was just a tracer initialized in the stratosphere, and we're watching where it's going. And during this event, you can clearly see this tongue of stratospheric air coming down and affecting a broad region of the eastern U.S. But one thing I'll point out, you don't see a lot of it in the boundary layer. Just for reference here, ozone sondes, like Ann Thompson was launching ozone sondes to this period, that's what this white line represents. And then this dash line, these little dotted lines, indicates where the airplanes were flying for Discover AQ, and they have a lot of instruments on board. And you can see that it just cut right through this intrusion. Okay, this is one of the ozone sondes from the Edgewood site, and you can see that there's a number of peaks in there that you might think are intrusions, but the model's indicating that they weren't. except for this one right above the boundary layer between about 2 and 4 kilometers. And we tried different stratospheric tracers, and the one thing the two that I'm plotted here, they both show that this is an intrusion, and one of them indicates that, yeah, it looks like it was in the boundary layer to some degree. So what does the aircraft data show? What I've plotted here are 2 different days. July 21st, when no intrusion happened. This is just a normal day. And here's the 27th. It's our poster child day. When an intrusion occurred between 2 and 4 kilometers, that's what I have outlined in this box. And you can clearly see on the intrusion day, the ozone was a lot higher than on the non-intrusion day, and the water vapor was a lot lower in the intrusion than in the non-intrusion day, as you would expect. Okay, so now what I'm showing are 2 intrusion days on the 27th, the same I showed before here, and the 14th. And this was the day that caught my eye up in the beginning. What sort of inspired me to do this work. And what you can see is that the ozone both days is pretty high, and the water vapor is pretty low. So that's consistent with what you would expect. But theta and the carbon monoxide as tracers of stratospheric air was a little less useful, and I think because there was so much mixing going on as it was coming down to the surface. And so the way I like to describe the air mass that was affecting the area was stratospherically influenced. It wasn't a pure stratospheric intrusion coming to the surface. Okay, so here's more model output. It's a stratospheric influence tracer at 700 millibars at different times, second through. So this is July 26th in the evening, going through the 27th. And this red box indicates when the airplane is flying during Discovery AQ. And you can see over time in the morning, this plume was coming closer and closer to Maryland. It happened to be right over us during the flight. It was it couldn't have been more perfect. And you can see the broad area that's influenced by this tracer. It's saying up to about anywhere from 25 to 50%, and then all the way up to 60% here in this reddish area of the air was influenced by the stratosphere. Okay, here's at 800 millibars. So I'm just coming a little bit down in altitude, closer to the boundary layer. And you can see that the influence wasn't as widespread, but it was still there in a number of places. So in the vertical, so what we wanted to do is see how much of this tracer was getting down into the boundary layer. And what you can see right here, and this is, again, a 700 millibar plot. We took cross sections A, B, C, and D here, and they represented A, B, C, and D. And what you can clearly see is this, it appears that this plume of stratospheric air is riding on top of the boundary layer, and it's only getting a little bit into the boundary layer itself. And I talked to a few people who know something about this, and they say that the boundary layer in the summer tends to be very energetic. And so it forms like an effective barrier to mixing this air down to the surface, but it's not impervious. And especially if you think about it, if this plume happens to come in the boundary layer is rising in altitude, it might entrain or fumigate some of that down. Okay, so to summarize, we do see during this Discovery AQ mission some events when stratospheric air was clearly influencing the free troposphere just above the boundary layer and to some degree in the boundary layer. But it wasn't anything that we would see in the wintertime or the spring, like out in Colorado, for instance. And that, I mean, it makes a lot of sense because where the source of stratospheric air, or this ozone in the lower stratosphere, upper troposphere, the ozone tends to be lower in the summertime than it does in the winter and springtime. So you're bringing down basically lower ozone than you would in the winter. Again, the energetic boundary layer seems to be capping or keeping this air from getting into the boundary layer, at least in the case that we were seeing. But these intrusions are likely impacting the boundary layer indirectly, and this is something we need to look into more because, you're just not bringing down ozone. You're bringing down low water vapor, low CO, low VOCs, and that's going to impact the tropospheric chemistry. And Ann Thompson, another ACAS member here, she found that about 25% of tropospheric air has some stratospheric influence at a given time in the summer. So we happened to look at box model results, box model study for these couple of events to see if the ozone production was indeed changing. And basically we just got very inconclusive mixed results, and we think that it's because there was so much advection going on that was just muddying our results. So we're going to have to look at like a global modeling study to get at this. But you know, the intrusions were pretty common. We found 2 days where it was a clear intrusion and several days where there were definitely was influenced by stratospheric air. And now that we have these new high-resolution global models, we can really look at this in detail and get some important information out of how this air is impacting the boundary layer. This is my last slide. Let me just show you an example of one intrusion. This is on April 6th to 7th, 2012, out in the western U.S. And we have 4 different horizontal resolutions: 2 by 2.5, 2 by 2 degrees, 1 by 1, half a degree by half a degree, and a quarter degree by a quarter degree. And you can clearly see from the scale, this goes from about 60 to 78, that these finer resolutions are clearly getting these fine structures that are impacting surface air quality. And this just shows some comparisons to AQS data, the black lines. And you can see that for the lower or the finer resolutions, that we're getting these events not perfectly, but better than we did with the coarse resolution. That's it. Uh-oh. Okay.
I was wondering, so the conditions that are bringing these fires to confusion that are behind the cold front?
Behind the cold front, yeah.
So when you're looking at the surface ozone concentrations, I'm wondering, generally we think of those conditions as oxygen and cold front as being out.
Exactly.
And so are the surface ozone concentrations on those days?
Yeah, yeah. That's part of the issue. Is if you don't bring down this air, yeah, if you don't mix down high ozone, you're typically getting cleaner conditions coming, you know, air coming down from Canada. But on that one day that I was really suspicious of, the high temperature was like 80 degrees or something that day, which is unheard of in July. And this clean Canadian air was just rushing down. It's a windy day, but the ozone was still in the like 50 to 60 ppb range. And I thought, this can't be coming from Canada. And if it is, what does that mean exactly? Like PRB ozone. And that's what made me think it was an intrusion.
So, are you going to be carrying this stratospheric tracer in the Just 5 model, or put it in the analysis?
We're talking about it.
I think that'd be great.
Yeah. Yeah. Yeah, we need to do a little more work to fine-tune the tracers because they have different advantages, different limitations.
Maybe as much a question has anybody ever detected high surface ozone levels at some of the higher elevation peaks in the northeast and South Carolina coastal trough?
I don't personally know of any, but Mayun, maybe Arlene. You don't know of any?
Maybe we'll move on, and I'll just use Brian as a poster child, what I'm going to say, because I know that he believes in this. But that if the speakers would try to stop a few minutes before their end time, because we'd love to have a lot of conversation at end time. Brian himself is a big advocate for that, and so we'll just keep on schedule. Thank you. Our next speaker is David Streets, talking about using NO2 data from the OMI instrument to constrain observations. And I believe this is work from your type meeting. Is that right, David?
That's right. So yeah, this is actually a description of the Tiger team that Daniel mentioned earlier. I think it was the 4th one, on trying to develop primarily relationships between satellite NO2
columns and NOx emissions over North America. This is the main thrust of this Tiger team, but we also have a second one that's being led by Brian Duncan, looking at new ways and reevaluation of long-term trends of NOx over North America. I'll give you a little bit of intro. Okay. Not correct. Do it this way. Oh, I can use this. A little bit of the philosophy of this particular Tiger team. In the past, we've done a lot of evaluation of power plants. These are the strongest NOx emission sources. In some ways, they're the easiest to look at. And we actually had a lot of success in China and in India, where we have very large sources of NOx from power plants, many of which are rather isolated and far from other sources of NOx, which makes things easier. But actually, when we came to the U.S. And started to look at U.S. power plants, it was not quite as successful as I think we hoped. A lot of the early work was done by Siwan from NOAA, who did 2 papers in the 2000s on power plants, which looked quite good, the results. But when Brian and some of our other team members started to look at a broader array of plants, the relationship between OMI columns and NOx emissions was not quite as good as perhaps we hoped. A lot of scatter, depending on time of the year when the observations were being taken, summertime versus spring and fall, location across the U.S. So I think more work needs to be done then, but we also need to look at other kinds of sources. And the idea is, if you imagine these are columns, the idea here is to try to identify locations where one particular type of source dominates the column. It's perhaps easy to sort of simulate that for power plants, but it's almost impossible for other types of sources. So we want to identify locations where we can say most of this column is soil-related NO, or due to emissions from an urban area, a wildfire, a transportation corridor, or something like that. So we have a team in place, and the idea is that we will, first of all, model columns with probably CMAC, perhaps WRF-Chem, and Greg is going to do that. I don't know if he's talking about that at this meeting. We are going to process OMI columns at Argonne, and then we will have members of the ACAS team who are specializing in particular aspects, particular source categories, if you like, that contribute. Brad, as we said, Brian, as I said, has done a lot of the work on power plants in the past. I'm not sure if Brian wants to work on power plants anymore, but we may be able to co-opt him. But Ben DeFoy and Zafang at my institution are looking further into ways of improving the power plant representation. We know that Tracy's worked on transportation corridors, freight corridors. Dan Cohen is working on soil representations. We don't have anybody to do anything on wildfires, but we're not sure if we're going to see much on wildfires. It kind of depends on what year is chosen for the modeling. We hope that Arlene will give us some more information on kind of the background levels of NOx, which are not particularly associated with any anthropogenic or natural sources within the U.S. And we have an informal relationship with Brad if he wants to use any of the results we get over oil and gas fields. So I'll tell you just briefly a little bit of an introduction about what we're doing in each of these areas, so that you'll get a feel for the contributions being made by ACAS team members. So for the columns, as I said, we intend to calculate column concentrations and compare with OMI across the entire US. For OMI, we've already started looking at various retrievals. We've used Domino for some of the work so far. We do intend to use the more detailed work that LACLAMSAL is doing that Brian mentioned on the new NASA Level 2 retrieval. Greg is going to model columns and tag sources of nitrogen. So he will trace nitrogen from particular kinds of sources to the column and calculate what the relative contributions of different source types are to different columns. Probably with CMAC, perhaps with WRF-Chem, it kind of depends on what year we choose. Right now we're thinking we'll probably do 2010 with CMAC. We, from the OMI side, would like to also do an earlier year before this famous Rho anomaly came into play and kind of reduced the number of data points. Some of these things are not fully resolved yet, which year we're going to use, spatial resolution, but we're working on that right now. We're just getting into this Tiger team, as many of the Tiger teams are. Arlene is using a global model to examine some of the contributions at a broad scale to NO2 over North America, trying to distinguish anthropogenic sources in some from what we might call a North American background, I guess some of which is composed of imported nitrogen from Asia, perhaps, and to look at some of the contributions of other natural source types like soils, which we'll also be working with Dan on, and lightning, which nobody else will be doing. This is work done with Lee Murray, and I guess there's going to be a poster, is that true, on this, that you can look at tonight. We're also working a little bit with Luke Valen from Columbia and Arlene's group as well on other kinds of sources, which I think she will refer to in her talk. We already started work at Argonne on cities and city clusters, and Zafang Liu is going to talk about that right after me, so I won't say anything more other than we have an array of 40 cities across the whole of the US that we're examining right now. So next talk will be by him. Soils, I don't have a new slide from Dan. This is just a slide from his ACAS 6 presentation where he is doing the development of soil NOx schemes to implement within CMAC. He'll probably say more about that later in this meeting. But we do intend to kind of coordinate his use of CMAC with Greg's use of CMAC, perhaps with some of the same emissions data, so that our output on soil NO can be used by him in his Dynamo model. We do have new activity on power plants. This has mostly been led by Ben DeFoy. I'm not sure if he's speaking here, but he will certainly have a post or two. On the left here is some of the work that Brian led a couple of years ago, looking at relationships between OMI NO2 and NOx measured by continuous emission monitoring systems in power plant stacks. And as I say, for some plants in some parts of the country, relationships were good. In other parts, they were not. And perhaps part of the reason they were not so good is that it's hard to distinguish some of these power plants from other sources of NOx. They may be on the edges of cities, for example. And this is part of the reason we're doing what we're doing, is to try and identify areas where we can say for sure this column is mostly due to the NOx from a particular source. Ben is looking at different ways to average the emissions from particular point sources. using Gaussian representations. In the past, we've mostly used points or circular averaging techniques, but we really need to have some information about the development of the NOx plume from a power plant, taking into account wind direction, wind velocity. And this is the kind of thing that he and Stefan are working on now to try to improve the way we represent a point source of emissions. He also is able to provide information on lifetimes, dispersion and chemical lifetimes for individual plumes. He may have more of that in his poster. For transportation, you've heard already in previous ACAS meetings the work that Tracy and her colleagues are doing on looking at truck and rail and freight emissions. And they right now are documenting that work. They have a paper going to ES&T letters, may be submitted already or very soon, yesterday. And a lot of that work has compared different emission representations for these freight transport activities, including their WIFE system at Wisconsin and the LADCO representation. We hope to be able to provide information on OMI for these same freight corridors that she's already looked at. Just a few slides about the trends work from Brian, and perhaps we can talk about this offline a little bit more. Locke Lamsal is doing a lot of new work to try to improve NOx emission trends because there are other factors affecting these trends that need to be taken into account if you're going to do this in an accurate and reliable way. So one thing he's been looking at is the seasonal shifting of NO2, NOx concentrations and NO2 columns, largely due to the fact that emissions have been reduced a lot during this time period. So this has affected the availability of regional NOx and has influenced kind of the seasonal distribution, which he's going to be taking into account. So he's sort of developing trends in other relevant factors that influence the resulting OMI trend. And this is sort of an example of taking into account these other factors and sort of reducing the residual, which is at the bottom, to very low levels. And so he's getting some new kind of trend information. We've done this sort of thing before. A number of people have worked on NOx trends over the last decade or decade and a half. And we have seen reductions in NOx, especially in the eastern US as a result of CARE and other EPA initiatives. And what we're seeing is that what he's seeing after doing some of this detrending of other factors is that most of the reductions occurred in the early part of the period. And actually since about 2009, there has not been a lot of further reduction. And this is shown in the two maps at the bottom as well. So just a quick summary then of what we're trying to do this summer. This is something I just put together to give an idea of the primary thrust in our work. We want to finish processing OMI for the whole country, at least in an initial form, while Greg is running whichever model we decide to run to get these sorted columns. And then we will, I should say, kind of categorized columns, which we will then sort. So we will have a map of locations in which certain kinds of anthropogenic and natural sources dominate NOx concentrations and NO2 columns. So we will be getting this kind of sorted information, sorted information from, not very sorted, cities, the kind of transportation corridors that Tracy's already looked at, the power plants that Brian and Dan are looking at, and Dan's soil regions. So we can then pass on to these people, and they can use it in analysis, comparison with emissions. Wildfires, if we have a year where there were significant wildfires, we will be able to process those as well. But we have no kind of commitment to do that and no sort of analytical technique set up to do that. But we will have the wildfire columns ready to go. So this is our plan. We are just starting now. We just got our initial Tiger II funds, and we're ready to go. So I'll stop now, and if you have any questions about what we're doing, I'll be happy to answer them for you. Yeah.
Thanks, David. I have a question, a practical question with respect to power plant. And have you looked at large power plants in the U.S. without NOx control versus large power plants with NOx control? And recognizing that most of the NOx really, I mean, are you able to compare and contrast large power plants with without?
I don't think Brian specifically did that. I think we basically chose large power plants, and we knew what their emissions were from CEMS data. So.
But were you able to look at large plants away from Kansas City? Right?
Mm-hmm. Some of them.
NOx control, one without, and compare and form.
We knew what the emissions were for the power plants that we chose. We didn't necessarily. Sometimes. Most of the time, especially for large and isolated plants that were far away from other sources. It wasn't quite as successful as when we did India and China, where we often had very large plants, actually new plants. See, we don't have many new plants to look at in the U.S., where during the period of OMI, initially there was no plant, and then there was a plant. This is what we like to be able to look at, big change in the signal. Here, we've just got plants not changing very much over time.
Just wondering if is your ability to give us trend information limited to the period of OMI, or are there other sensors data? How about that?
We could go back earlier. The resolution of early instruments is not that good. So we prefer, I guess, there have been comparison studies of different satellite instruments, and they're generally comparable. But I think we prefer to just have one instrument, so we don't get into any difficulties with different instruments. Unfortunately, we lost a very good instrument, Skiamaki. We have no more data since 2012. That was a good instrument. And we have the new GOM. But I don't think it's really advisable to go earlier with a different instrument. I think, we have no guarantee the trend will be consistent.
Right at the beginning here, in terms of the bottom up from all these components, when you start talking about the last time, getting to use what we see in space for what the resources are at, but I think that's like last time. When you start thinking about and using data that's not as updated as the latest data.
Mm-hmm.
Does the parts of the country look match like
Well, we'd love to have time of day information, and one day we will. But right now we don't.
I'm a little bit of a slacker on my timekeeping, I will say. And so I might say that we'll have time in the break to be discussing more stuff, but that's a good point. Maybe we can move on to as our last talk before we go into the break. Thank you very much, David.
My topic today is about re-evaluating the relationship between NOx emissions and OMI satellite observations over U.S. urban areas. Actually, this is follow-up work of our previous efforts on estimating urban NOx emissions from OMI observations. In the last ACAST meeting, we showed the relationship between NOx emission and OMI NO2 observations for about 50 U.S. urban areas. And although there's a good linear agreement between them, the data points are a little bit scattered. So we are wondering whether the results can be improved. We noticed the recent work done by Valin et al. About the effect of wind speed on the OMI NO2 columns. They showed OMI NO2 map at for the city of Riyadh at a slow wind speed condition and a fast wind speed condition. And we can see clearly from these figures that the presence of fast wind decrease the OMI observation at the urban center, but increase the OMI observation in the downwind region. That means wind can change the OMI satellite observation. So the purpose of this study is to check whether it's possible to refine our previous analysis by taking into account this kind of wind effect. For the OMI NO2 retrievals, we used the KNMI Domino version 2 product for the whole period from 2005 to 2013. The wind fields are from the ERA interim reanalysis. To increase the number of valid OMI samples, we set the filter criteria as relaxed as possible. We also combined the 3-year data in analysis so that most of the result I present in this presentation is a 3-year average result. For a single urban area, we rotate the valid OMI measurements to align the wind direction and apply the oversampling technique. This slide shows the average spatial distribution of summertime OMI NO2 map over US for the period from 2005 to 2013. The lower left figure is the OMI NO2 map for all the valid OMI measurements, and the upper left figure is for data with wind speed lower than 3 meters per second. The difference between the two figures are shown on the right, and you will see there's a huge difference between the two figures. In the slow wind speed map, urban NO2 signals are clearly higher, while the rural NO2 signals are lower, particularly in the northeast US. So this result again shows the fast speed wind can change the OMI NO2 patterns. This figure gives the urban areas we selected in this study. We examined the top 60 urban areas based on the population and finally select 40. They together account for about 23% of the total NOx emission and about 53% of the total urban population in the United States. For each urban area, we use exponentially modified Gaussian function to fit the OMI NO2 line densities along the wind direction. I don't know what's wrong with the equation here. I just noticed it in this morning on this computer, but it was okay on mine. Anyway, generally, the key component of this equation is a convolution of Gaussian component and exponential component. Since the integration of this component equals 1, the scale parameter alpha physically means the total number of NO2 molecules observed, or we can call it OMI observed NO2 burden over a hotspot. Another benefit of using this method is that it has been reported that under the fast wind speed condition, the NO2 lifetime and NOx emissions can be estimated directly through the fitted parameters. That means we will get a top-down NOx emission estimate from the satellite observations directly. So we can further compare it to the bottom-up NOx emission estimates, such as the EPA National Emission Inventory estimate. This slide shows an example for how we do the analysis to Chicago. To make full use of all the valid OMI samples, we we generate the wind-aligned OMI NO2 map for both the slow wind condition and the fast wind speed condition. The criteria for the wind speed is 3 meters per second for the slow wind and 5 meters per second for the fast wind. For both the case, we will use the exponentially modified Gaussian function to fit the NO2 line densities along the wind direction. And for the slow wind speed condition, we will only use the OMI NO2, the fitted results for OMI NO2 burden, which will represent an OMI observation without wind effect. And for the fast wind speed condition, we will use the fitted results for OMI derived NOx emissions, which will represent a top-down NOx emission estimate. And the results shown in this figure, please note that each point represents a 3-year average result. So the trend here are 3-year moving average trend. The blue line is the OMI NO2 burden at slow wind speed condition, and the red lines are top-down and bottom-up NOx emission. The green line is the NO2 ground-based measurement from the EPA air quality system database. And we can see clearly 4 lines correlate with each other very well. From 2006 to 2012, NOx level over Chicago area decreased by about 30 to 36%. So we do the same analysis to all the urban areas we selected, and the result, scatter plot results shown here. The left figure shows the NEI emissions versus the OMI observation, and the right one shows the OMI-derived NOx emission versus OMI observation. Compared to our previous results, the linear relationship of current work is much better. The residual mean square, which is a parameter, characterizes the scatter of the points, decreased from 128 to 47 or 67. We can also compare the NEI NOx emissions to the OMI-derived NOx emissions. Overall, the bottom-up and the top-down NOx emission estimates are in good agreement. The differences may provide some information to the national emission inventory developer, like whether the NOx emission of an urban area is overestimated or underestimated. And this figure shows the 3-year moving average trend of NOx level for all the urban areas we selected. At the national level, the OMI NO2 observation are in excellent agreement with the NOx emission and the NO2 ground-based measurement. From 2006 to 2012, the NOx level over the selected U.S. urban areas decreased by about 33% to 38%. And if we use the same annual average growth rate, decrease rate to the whole period from 2005 to 2013, we can estimate the NOx level over these selected urban areas decreased by about 41 to 47%. And this decrease rate is about 10% larger than our previous estimate, probably due to the improved methodology used here. So finally, the conclusion of my talk, we found the presence of wind can significantly change the OMI NO2 pattern, and it will be better linear relationship between NOx emissions and OMI NO2 observations if we compare the emission with the OMI observation at the slow wind speed condition. And based on the new calculation, we found the average NOx level in the summertime of major U.S. urban areas decreased by about 41 to 47% from 2005 to 2013. So that's all for my presentation, and thank you.
Thank you so much, and thanks for getting us back on schedule as well. Any questions? Yeah.
So for your comparison with NEI, did you just use 2005? What NEI did you use for that?
Oh, I used I use NEI for NEI estimates 2005, 2008, and 2011, and for the other years it's interpolated by the NEI trend. So and the NEI data user here is the counties. For the urban areas, I select the counties covering these urban areas and use the NEI emission directly.
The linear relationship between OMI-NO2 and the NOx emission assumes that you've got a fixed lifetime for NOx.
Yes,
right?
yes. At least for the slow wind speed condition, it's like that.
But the lifetime should depend on the NOx concentration itself. So would you expect some curvature?
I don't know why, but at least in the results shown here, it seems that the meteorological effect is more important than the lifetime, the concentration effect itself. So.
Great. Well, we will have more conversation over our break, and the next session when we come back, we'll be back here about 11, and then we have a treat. Everybody goes back home.
Sorry, I was looking at an older schedule and I thought I was talking to